Morning, everyone. Hopefully you're doing well. In this video, we're going to find all zeros of a function, polynomial functions, p of x, x power 4 plus 81x squared. So we need to enter the answers as a comma separated list. So we need to identify all the zeros. So first of all, let me remind you, when you have a polynomial of a certain power, I mean the degree, if the degree is 3, we know we're gonna have 3 zeros. If the degree is a 4, the highest degree is 4, we're going to have 4 zeros. If the highest degree, when we say highest degree, that means the degree. I mean, if the highest exponent, so if the exponent is 4, we're going to have 4 zeros. If the exponent is 10, we're going to have 10 exponent. So the first part we can see here, if we rewrite our polynomial p of x equal x power 4 plus 81x squared, we know we can factor out x power 2 because the common factor between x power 4 and 81x squared is x power 2. So we have left x plus x squared plus 81. So you know at some point here, if you set, because to find the zeros, you can set your polynomials equal to 0. Or you can use the techniques of p divided by 1 to identify all the potential zeros. So first of all, if we set the polynomial p of x equal to 0, we're going to have x squared times x squared plus 81 equal to 0. That gives us x squared equal to 0. So x would be 0. So for us here, it's like we have x times x. Let me show you something to make sure we have all the zeros we need. So for these functions like here, for us is the same thing having x times x squared plus 81 equal to 0. So you can see that you have x equal to 0. That's the first one. The second one is x equal to 0. That's the second one. And we're going to have, if we continue in this side, x squared plus 81 equal to 0. Now, our problem is definitely we don't have x squared minus 81 equal to 0. That would give us x squared equal 81. Then we would take the square roots of both sides. X would be equal to positive and negative 1. So clearly we can see here we have some complex zeros. Instead of having real zeros, we're going to have complex zeros. As I stated before, every polynomial of degree n greater than 1, I mean the exponent is greater than 1, has exactly n zeros. So if you have the n power 10, we're going to have 10 zeros. So we already have 2 zeros here. So we need to have 2 more. So if you subtract 81 from both sides, then we end up having x squared equal negative 81. Now, taking the square roots of both sides, remember when you take the square roots of both sides here, it would give you x squared equal plus and minus square roots of negative 81. But you know a square root of negative 81 is not a real number. So you can rewrite it as x plus and minus square roots of 81 I square, let's say 81 I square with, of course, negative 1 equal I square, right? So you know that already. So now by taking the square roots of negative square roots of 81 I square, that give you plus and minus 9i. So what are the zeros of P? So we can conclude the zeros of P are, you have 4 of them, because remember here we have x equal negative 9i. So you're gonna have, let me put them inside of a parenthesis. We're gonna have 9i, but you have 0 twice, and you have positive 9i. So those are the zeros of the polynomial p. Okay, so we answered the first question. So to answer the second question, which is B, they ask us to factor out P completely. So how can we factor P completely? Because now we know what is x squared plus 81 in terms of factors, because we know the two factors of that. So we have 9i and negative 9i, which are the zeros of these polynomials. So what we do, remember, as we said, 9i and negative 9i, since 0 occur twice in the complete factorization of P, so we have 4 zeros. That's exactly what we have here. Now, to factor completely these functions, we know P of x would be, we have the x squared. Now, instead of writing x squared plus 81, we're going to write x minus 9i and x plus 9i. So this is the complete factorization of P. Hope this video helped you to do more examples in this category. Let me know if you have any questions, and don't forget to subscribe for more videos. Take care.